All right, hi guys, this is Mrs. Rooker again. Today, during this lesson, we are solving equations with variables on both sides. So again, we're just kind of building on what we've done in the previous lessons. This is just taking it one step further. So just like on the day 3 notes, we are going to do these first problems. And as we go, we are going to identify the properties used in each step. So you might notice in number 1, we now have a lot of stuff going on both sides of the equation. So that's kind of the difference from day 3 and day 4. So what we're going to do is look at each side individually and see what we can simplify on each side. So I'm going to put a line down the middle. And I'm just going to look at the left side. And I'm going to look for parentheses. I'm also going to look for like terms. So obviously there are no parentheses on this left side. There are also not any like terms. So I can't do anything on the left. So I move to the right instead. So I ignore the left. Now just look at the right. I do have parentheses now, which means I can get rid of those parentheses first. So to get rid of the parentheses, I'm going to distribute the 5 in there. 5 times y is 5y. 5 times negative 2 is negative 10. So that was the distributive property. We didn't do anything to the left side, so I'm just going to leave it as it was. All right, now this is what's different from day 3 is we have y's on both sides of the equation. I don't like that. I need to move them so that they're both on the same side of the equation. So here are my y's on different sides of the equation. So once I've simplified the left and simplified the right, the next step is always to get the y's on the same side, or get whatever variable we have on the same side. It doesn't matter which one you choose to move, but I like to move the smaller one. The reason is because then we'll end up with positive numbers on both sides. So we'll usually end up with positive variables on both sides. So the smaller one, the negative 3y, needs to move to the other side. Whenever you're moving something from one side of the equation to the other side, you have to do opposite of what it was. So this was negative 3y. I have to do opposite of negative 3y. That's plus 3y. But whatever I do to the left side, I have to do to the right side. And I always line it up under the other y, because they're like terms, those will combine. All right, so those cancel. All we're left with on the left side is 14. On the right side, we'll have 5y plus 3y, which is 8y. And then we'll still have this minus 10. So what we did here was we added something to both sides. So that's the addition property of equality. All right, now this is the same as what we've been working on. You're just trying to get y by itself. So the goal is to get y by itself. You have 2 things you need to move. You need to move the 8, you need to move the 10. You're always going to add or subtract, or you're usually going to add or subtract on these. So we're going to move the minus 10 first. The opposite of minus 10 is plus 10. Whatever you do to the left side of the right side, you also have to do to the left. 14 plus 10 is 24. And the 10's cancel. Since we added to both sides, that's the addition property of equality again. All right, and then the final step, we need to get y by itself, so we need to get rid of the 8. Right now this is 8 times y. The opposite of multiplying by 8 is to divide by 8. 24 divided by 8 is 3. I usually flip this around, so it'll be y equals 3. So that's our final answer. And that was, because we divided on both sides, that was the division property of equality. Sorry, it's a little crammed there. All right, so feel free to pause the video if you need to kind of write all that down, if you haven't already. All right, and then the next one is a lot simpler, or more simplified, but we do still have variables on both sides. You can see we've got an A over here and an A over here, an A on the left and an A on the right. Okay, I guess I was a little ahead of myself. I'm going to draw a line down the middle. Look at the left side. There's nothing I can simplify over here. Look at the right side. I can't simplify that because there's no parentheses. There's also no like terms. So the next thing I'm going to do is get the A's on the same side. I had said on number 1 that I usually like to move the smaller one. And I can do that. But the issue is if I move the smaller one, there's going to be nothing left on this side. So this is one of the cases where I'm actually going to move the bigger one. So I'm going to move the 5A. Remember, to move to the other side, you need to do opposite. This is a positive 5A, so I need to subtract 5A. Whatever I do to one side, I do to the other side. 3A minus 5A is negative 2A. Those cancel. I'm left with negative 9 on the other side. Since I subtracted something on both sides, that's called the subtraction property of equality. And then the next step is just to get A by itself. Right now this is negative 2 times A. The opposite of multiplying by negative 2 is to divide by negative 2. A equals, remember a negative divided by a negative is just a positive. So this is going to be 9 over 2. Sorry, that 9 looks like an A. A equals 9 over 2, which I would be fine if you put that as 4.5, or you could leave it as 9 over 2. Either one is totally good. Since I divided by something on both sides, that's called the division property of equality. All right, so yeah, feel free to pause if you need to write stuff down. Sorry. All right, so moving on to number 3. So first step, draw a line down the middle, look at the left side. Is there anything you can combine or simplify? No, they're not like terms, you can't combine them. Look at the right side. Is there anything you can combine or simplify? Yes, I can distribute into the parentheses. So this will be negative 2 times 2 is negative 4. And then negative 2 times negative 5 is positive 10m. Which should look a little interesting. Do you notice that we have a lot of similarities between the left and the right sides? So your next step should be to get your m's on the same side. So you're going to move one of the m's. It doesn't matter which one. So let's say you want to move this m to the other side. The opposite of plus 10m is minus 10m. Whatever you do to one side, you do to the other. And I line it up under the other m because they're like terms. But you might notice here, they're going to cancel on both of them. This cancels, this cancels. I'm left with negative 4 equals 4. Or, sorry, negative 4 equals negative 4. I don't have a variable left. I don't have an m left. And the whole point was to solve for m, right? Wasn't that the whole point? Well, if m's not there anymore, then we're not going to have a normal solution. If m's totally gone, we have 2 options. We either have all real numbers or no solution. And the way we decide if this is all real numbers or no solution is we look at this statement and we decide if it's true or false. Is negative 4 equal to negative 4? Yeah, they're the same, so they're equal, which means our answer is going to be all real numbers. You can write this as ARN, or you can use, this is the all real numbers symbol. It looks like an R, a capital R with an extra little line on it. Any of those would work. ARN, all real numbers, or the all real numbers symbol. What all real numbers means is that any number in the world that you can think of that you want to plug in for M would work to give you a true statement. So like, let's pretend you want to plug in 1. 10 times 1 is 10, minus 4 is 6. 1 times 5 is 5. 2 minus 5 is -3. -3 times -2 is +6. 6 equals 6. That's true. You also could have plugged in 0. You could plug in 5. You could plug in 5 million. It doesn't matter. All of them will work. All real numbers work in this problem. All right, let's move on to number 4. So on number 4, look at the left side of the equation. Is there anything you can simplify there? Can you combine those? No, you cannot, because this doesn't have a y on it and this one does. Look at the right side. Anything you can simplify? Yes, you can distribute. So we'll have 15 minus 3 times 2 is 6y. So we have 4 minus 6y and 15 minus 6y. After you've simplified left and right, the next step is to get the y's on the same side. So it doesn't matter which one you move. I'm just going to add 6y because I know that'll cancel out this one. Whatever I do to one side, I have to do to the other. Which again is interesting. These are both going to cancel. I'm left with 4 equals 15. Remember I said if the y's cancel, I'm not going to have a normal solution. I'm either going to have all real numbers or no solution. So I have to look and see, is this true or false? This is a false statement. 4 does not equal 15, which means my answer is no solution. You might also see this as NS, or I write no sol a lot. That's how I abbreviate it. What this means is there is no number in the world that will work to make this equation true. It's basically a broken equation that will never be true. All right, so feel free to pause on those. What I would like you to do now is try to do A on your own. I'll give a few hints before you do. You're going to try to see if you can simplify anything on the left, see if you can simplify anything on the right. If you can't, then you'll skip ahead to the next step, which is to get the x's on the same side. Okay? So try that one. So pause your video and try that one really quick. All right, so hopefully you got a chance to try A, and I'm just going to walk through it together really quickly. You're going to want to get your x's on the same side because the left and right are already simplified. So I'm going to move the 3x. I like moving that one because it's the smaller one. And then you'll be left with a positive number here. So remember, when you move something to the other side, you have to do opposite of, sorry, my pen's glitching out. You'll do opposite of what it was. So 7x minus 3x is going to leave us with 4x. We still have this minus 5. These x's will cancel. We'll still have the 7. All right, and then the goal is to get x by itself, so we need to move the 4 and the negative 5. I'll move the negative 5 first. Opposite of minus 5 is plus 5. Whatever I do to the left, I do to the right. I'm left with 4x equals 7 plus 5 is 12. And then the final step is to get rid of the 4. Right now this is 4 times x. The opposite of multiplying by 4 is to divide by 4. And I haven't been the greatest about doing this because I'm trying to go quickly, but you can always, and you should always, plug your answer back in to check. So you can plug 3 in here. This is 7 times 3 minus 5 equals 3 times 3 plus 7. 7 times 3 is 21 minus 5 equals 3 times 3 is 9 plus 7. 21 minus 5 is 16. 9 plus 7 is also 16, which means it works because we got something true. All right, moving on to the next one. So this is more steps. The first thing you're going to want to do is look at the left side of the equation. Simplify everything you can on the left. You can combine these two terms. 1x minus 5x is negative 4x. The 12 just stays as is. And then this one you're going to also simplify. You can distribute. 4 times 3 is 12. 4 times negative x is negative 4x. This is another one of those weird ones where your next step is supposed to be to get your x's on the same side. To move them, you do opposite. But those will cancel. You'll be left with 12 equals 12, which is a true statement, which is like number 3 up here. Since that's true, our answer is all real numbers. I'm going to have you pause the video and do number C or letter C on your own. So pause the video right now. Here's your solution to C. You combine like terms first and then move things away from the A. All right, so we're going to do a quick little word problem. Gamersforlife.com offers streaming for video games. Gamers have 2 options. Option 1 is if they have a membership, they pay an annual fee, but then it's just $1 per game. Or option number 2 is $5 per game, but no fee, no annual fee. How many games will Cody need to play in order to make both options equivalent? So we're going to make an equation, to compare the 2 different options. So I'm going to do option 1 is going to be the left side of my equation. So it's going to be $20 that he pays once a year plus $1 per game. I'm going to call that 1G. I don't know how many games he's going to play. So that's why I'm going to do $1 times the amount of games he plays, 1G. And that's going to equal, the other side of the equation is going to be the non-members. They do not have to pay a $20 fee. All they pay is $5 per game. I kind of spread that out more than I needed to. So this is my equation. One side of the equation is option 1. The other side of the equation is option 2. Now I'm going to have you guys solve this one so that you can figure out how many games he'd have to play to make both options equal. To solve this, make sure you get your G's on the same side first. So pause the video really quick and solve it. All right, when I solve, I'm going to move this G to the other side. So I'm going to subtract 1G. So I'm going to be left with 20 equals 5G minus 1G is 4G. And then to get rid of the 4, I divide by 4. So 5 equals G. Or G equals 5. Meaning if he plays 5 games, then they'll be equivalent. So what that means is if he plays more than 5 games, then it makes sense to get the membership. All right, sorry, I'm a little rushed. I'm trying to get through everything in about 20 minutes. So let's do these little steps. Step 1 is use the blank to remove parentheses. To remove parentheses, you use the distributive property. This is definitely something good to write down because sometimes it is hard to remember the steps. Step 2, blank the expression on each side of the equation. Simplify. Step 3, use the properties of equality to collect the variable terms on one side of the equation. So that means all the x's need to be on one side of the equation. And then the number or constant terms on the other side. So variables on one side, all the other numbers need to move away from the variables. Use properties of equality to solve for the variable. And then check your answer or solution in the original equation. All right, so that's it. Make sure to finish up these notes, bring them to class. Also come with questions. All right, thank you guys.